this year's award goes to ADASS. ADASS started 1987. Now, after many years, now it holds 17 million records, 170 million citations, 700,000 articles, and there's links to over 13.3 million records to different databases and journals. So here is Alberto. I need to run down to get the prize.
There's an actual prize.
Is there an actual flag?
Wow.
The words here says ADASS 2023 software prize. So I did not assemble it. So make it easier for you to travel back. And I'll give you the all the other pieces you can assemble, and it will stand on the desk.
It's wonderful. I hope it makes it through TSA, but looks great. I didn't know this was cool.
It did. It made from
Okay, awesome.
from my place to you. So take it away.
Thank you so much. And thanks everybody. I mean, I can't express enough gratitude for this prize. I'm here to accept it on behalf of our team, obviously. And it's very humbling to be in front of such a talented group of people talking about software and having to kind of present a project that really represents most of my career. So let's get started and okay. So if you've been living under a rock or playing too much with Google and ChatGPT, here's a recap of what ADASS is, in case you lost track of what we do. First of all, it's a NASA-funded project. Most people know this, but not everybody. Some people forget it. And even though we have focused on supporting the astronomy community, 2-3 years ago, we started also expanding our reach into doing a better job for planetary and science and heliophysics. We're not just a bibliographic service. We try to provide all the usefulness to researchers in astronomy in these disciplines. So we not only index the literature, but we aggregate and curate scholarly content, enriching it with links to data sets, software, etc. So we do this by using and developing software. And so in this talk, I will focus primarily on the use of, thank you. I will focus on ADASS as a software system and tell you a little bit about our journey. I will divide sort of this narrative into 3 parts, which were really determined by different milestones and inflection points in technologies and the evolution of our team. So the early ADASS years are at the very beginning, from 1992 through 2007. Then starting in 2008, we underwent a restructuring and technology sort of readoption in our system. And then I'll conclude talking about what's been happening since more recently from 2021 and having a look into the future. So the early days, 1992. So the project that is the ADASS as known today really began around 92. ADASS was really part, the literature component of ADASS was part of a larger system, which was truly a data system. That's why it's called the Astrophysics Data System. And it's something that then was discontinued in favor of the web and the virtual observatory and so on. But if you're old enough like me, you will remember this interface, which actually ran through 2007 or so. So this was originally an interface developed on an X window client prior to the web in 92. And, it had all these fun boxes that people used to be able to fill with their closed eyes because they knew it so well. Right away in 1993, we realized the importance of having not just a literature search, but we integrated object searches by connecting to the Sinbad database. So this was, again, before the web. So we were using sockets and TCP/IP. In '94, and this was one of the primary responsibilities when I joined the project, we brought ADASS to the web, and so it became possible to implement most of the functionality of the system, both from a user interface perspective, but also from a server-side functionality on the web. And this is when things started to take off. So then we started populating the database with interesting scientific content, not only abstracts, but also full text. We started digitizing the Astrophysical Journal letters, which made it online in 1995. And that really showed the power of bringing scientific content to the web. We followed this up by digitizing more content and then starting linking publications with data sets. And we even started the first mirror sites that was hosted by the CDS. In '97, we incorporated citation data, which again became incredibly useful for research in astronomy. I don't have to tell you why. And also we incorporated content from archival, which was becoming a very popular platform back in '97 for astronomy research. In '98, a study by Michael Kurtz showed that actually ADASS was getting more usage than print readership, as evaluated by how many people used to check out content from libraries. So this was a major accomplishment. And all of this was done by a fairly small team. There were 5 of us working on this project. And so we were able to deliver a lot of value for a really small, agile project back in those days. But we weren't done. We continued this effort by bringing more functionality and personalizations. We started extracting and processing citations from the full text of papers. We incorporated usage data and different rankings based on both usage and citation. The mirror sites proliferated. By the time we were done with 13 of them, but in 2001, we brought online the 10th one, and we started digitizing retrospectively historical publications so that we would have a complete record of the literature in our system. We introduced notifications. Many of you were receiving this kind of email notifications based on your preferences. And then we started implementing full text search on our scanned content, libraries, other customizations, included the ability to have feeds of content on a daily basis. We introduced a simpler version of the search. Open URL links allow you to go through your library subscriptions to get to the content, and then a full login system that allows you to do more customizations. So in this phase, we added one more person to be able to do all of these things starting in 1999. And so this was, again, quite an accomplishment in terms of the usefulness of this service, given the effort involved. So here we come in 2007, and we have a pretty good feeling that the system is not only useful, but it's actually used by everybody working in research in astronomy. So we estimated that we had 100% penetration. Every astronomer used ADASS because of its features. And in fact, many more people outside of astronomy used ADASS, both sort of accidental users that through web searches would come to our website, but also researchers in other areas associated with astronomy, so high energy physics and the likes. We also ended up with a fairly complex infrastructure, not super complex, but multiple components built around the system. And then we started recognizing that we had some issues in terms of sustainability of a system built this way. As you can imagine, this grew organically. There was a small number of people involved in software development, and we used whatever tools were available to us. So most of the code was C and Perl code. Eventually, we developed some additional Python code, but everything was more or less custom built. Even though we use plenty of open source tools, the code was really designed to squeeze the performance and to build the features that we were interested in. And this came to be a problem at the time when Gunther Eichhorn, who was the lead of the project, left us in 2007. He had developed the entirety of the search engine and user interface. And so we were left with a case of having a complex system without much documentation and with the lack of knowledge and experience to maintain part of it. So this is what they call a case of the big ball of mud. At least this is in software development. This is the PG version of what is usually being called. But it's a system that is developed organically, opaque and undocumented, so it's hard to modify without really understanding what the consequences of these modifications are. So we knew, this is when I took over as project manager, and I knew we had a problem to solve. So thankfully, this was also a time when we were preparing ourselves for a review by NASA in 2008, and we were able to write a proposal that explained not just the problem, but how we were going to tackle it. So we were asking NASA for additional support to help us through this rebuilding of the infrastructure of the system. And to their credit, really, NASA stepped up and provided us with the resources to do that. So that brings us to phase 2, the rebirth of ADASS. We did not have, specifications as such, but we had some principles that we wanted to apply for having a new phase of our system. First of all, we decided that we were going to use widely supported open source technologies and packages. We no longer had a need to squeeze every last bit of performance out of the code and the hardware, but we could afford to seek stability and maintainability over performance when we were developing code. And we're also looking for projects that had similar goals and tried to work together with them in developing digital library platforms that could be adapted to our goals. So this sounds good, but this was really the beginning of a journey that proved to be quite challenging, actually, in retrospect. So in 2009, we started being able to hire people who could help us through this. At the beginning, we explored sort of the functionality that we were seeking in terms of the search features and what the user experience would be in terms of what information was going to be necessary to present to the user. So we iterated and created prototypes that we launched as part of something we called ADASS Labs, and this helped us to collect feedback and understand limitations of the code, but also gauge the interest in different features that we were going to implement. So originally this was running the same search engine, but with different views of the search results. Then we started using Apache Solr, which is a popular open source search engine, and a backend to handle all of our metadata. So this was in 2013. In 2015, we launched a JavaScript application that we built ourselves. We codenamed it ADASS Bumblebee. And this is also when we started introducing the cloud as a component of our architecture, so that the JavaScript application would use a JSON API in the cloud. Having created this new framework, then we started adding features. The goal, of course, was to provide the same functionality that ADASS had, but in this new platform. So we added new things such as ORCID integration because it became a priority. And we also worked on infrastructure in the back end to make sure that we could deliver the functionality that we wanted. So there was, as you can imagine, a lot of back office work as well as front end until 2019, when we reached and surpassed, in fact, parity in terms of the features that our system was providing. And at that point, we declared that the old interface, so-called ADASS Classic, could be discontinued. This is also when I started receiving hate mail from some of you all, because you love the old ones so much. But, overall, it went quite well. And And this effort required actually a lot more resources than I personally had originally imagined. By the end of this evolution, our team grew to about 13 FTEs, give or take, which is really not surprising if you think about, you know, the scope of what we're doing and also the advances in technology that we introduced all along. Here's just a quick view of the different pieces of formats and technologies that we considered throughout this journey. As you can see, there's you know, there's a lot to go through, experiment, and learn about before you can make choices. So this is just a view of what was on our plate. And this led us to the infrastructure around 2019, which is still the current infrastructure, where we have backend processes and pipelines running on premises, which is still cost effective for us, that you see on the right. So this is where we do data ingest, enrichment, and indexing. And then the data itself that is used by the user interface is migrated to the cloud through replication. And that's where we have a system with microservices and Kubernetes for orchestration. And the user interface talks to the API. And all of this is now in the cloud. So what we gain through this is not only, you know, stability, but also, you know, essentially everything is better. First of all, the search engine is much more powerful and extensible. We took an open source package, Apache Solr, and we extended it. Actually, the search syntax that we support is not the standard Solr search syntax, and you can do things such as second order operators over queries. We also included in the search itself citation and usage graphs. So this is something that we wouldn't have been able to do with the stock version of Solr and Lucene. We created a well-structured and well-documented JSON API. This made it possible for other people to develop packages that actually talk to the API. The most used Python package was not developed by us, but by Andy Casey. And a modern user interface. So the search experience is much richer. You can filter and you can explore results in a way that you couldn't do before. On top of this, now it's easier to develop layered services such as visualizations, because again, we have a well-documented API and we can use it to then do this ourselves to let other people build additional functionality. And in the back end, this is a continuous improvement, but we have a scalable and redundant infrastructure that we're building on. So as an example, we're now introducing Kafka as part of the data management and pipelines management in the back end. Okay, so this brings us to modern times, starting in 2021. Why 2021 and what might the future include for us? So this is what I call a new frontier for ADASS. What happened in 2019, the NASA Science Mission Directorate published a white paper detailing a strategy for data and computing, which included support for open science initiatives. And one of the goals of support for open science was the creation of a interdisciplinary literature portal that could be used to better understand how NASA data is used and to provide services to the research community across the disciplines. So of course, it was right away recognized that ADASS was filling this function for the astrophysics section of the NASA science research community. And so, you know, we already checked a lot of the boxes in the open science requirements. We index publications, we make open access and published records, we merge the metadata for those records, we enhance records in our system, we link to data sets, we index software, etc. So NASA asked us to start expanding our services first to planetary science and heliophysics, but later on to the rest of the NASA S&D disciplines. The biggest one of which is Earth science, which is a huge field. But NASA science also includes now biological and physical sciences. So there's yet one more discipline, a fifth discipline that we will need to cover. And because these researchers are not very likely to go to a website called the Astrophysics Data System, we're also going to introduce a new platform called the NASA Science Explorer, or SciX. This is a brand new logo that we just selected. So this is what we're going to be doing for the next little while. We're going to be launching the NASA Science Explorer at the American Geophysical Union in just about a month. And what it is basically ADS on steroids. It's the infrastructure of ADS, but it's content from additional disciplines, and it's features that are useful for a larger community of researchers. So we will have discipline-specific features that we are developing and that we will need to market to those research communities. So one of our bets in doing this is how to actually be able to scale up in an efficient way, because of course, we don't want to waste effort or resources. One of the things we're betting on is that we can use emerging technologies, specifically AI and machine learning, to help us do a lot of the activities that traditionally in astronomy we've been doing, with curation and collaboration and integration of metadata enrichment in our platform. So our bet is that we can use AI and ML to scale up these efforts and do many of these things more automatically. As these are some of the examples of the things we're working on. For instance, automatically assigning concepts drawn from the Unified Astronomy Thesaurus to all the records in astronomy, or extracting and disambiguating planetary feature names, which is useful for obviously researching planetary science. And part of doing this in this open science framework also means that we're not only delivering a service, but we will also be generating data and services that we hope will be used by all of the communities that we serve. So one of the things that we'll do is, as we generate data sets and models to make progress in all of these efforts, we will release those to the community. As an example, we generated annotated data sets for named entity recognition in the astronomy literature that's been published. We have created a discipline-specific language model in astronomy that's called Astrovert, that's also public. And we've been participating to workshops in information extraction. The most recent one was just less than a month ago. All of these have had data challenges where other people take our data sets to perform certain tasks, and often the results of the community surpass the results of our own implementation. So this shows that there's value in following these open science efforts and making this content available to a larger discipline. So as I mentioned, we released Astrovert in 2022. This was the first step in what we hope is going to be additional releases of specifically language models. In 2023, a collaboration called Universe CBD released AstroLlama, which is a fine-tuned version of the Llama 2 language model, which is an open source model. I'm a member of that group. So this is nice to see that it's becoming a community effort rather than having single projects working on it. In 2024, we expect the release of a large language model developed by the NASA Science Mission Director. So we have been providing data to them, and they're developing this in partnership with IBM. So I would like to spend the last little bit of my talk to talk about what the future might hold, especially as it relates to our use of these new AI technologies. And by our, I mean archives and this community, really. I like to think as AI to be used as infrastructure, and also in particular large language models, which are all the rage right now. how they can be used to benefit the services and data that we provide to our community. So first of all, large language models are not just chatbots. They're models that can be used in a variety of ways. The chatbots made them popular, but you can use the same models for doing tasks like information extraction, metadata enrichment, coding support. Maggie Lewin in her talk, she showed multiple ways in which these language models can do very impressive things. And one paper that I wanted to point out too is by Joe Chuka, who worked on hypothesis generation using language models, guiding language models through the analysis of papers and proposals. The big problem with this is that we need to trust that these systems, which are truly black boxes, are giving us things that are reliable and important for us. So we would like to understand how the system works, but these systems are really too large to really have any trust in analyzing how they work inside. The bigger problem, I think, is trying to understand what content went in, because when these models are released, they've been fed anything that the developers could get their hands on, typically. And so we need to take the magic out of the equation, because as scientists, we don't like magic. We like predictive things. So this is one of the things that we've been doing. The talk by my colleague Sergio Blanco Quaresma 2 days ago was showing some of the directions in which we're going. We're using search over our curated data sets to guide language model towards some useful functionality. Also, I should say, there's a great talk by our colleague Josh Peak, I think it's called Science at the Speed of Trust, where he discusses this. So this is a larger problem. It's not just about language models, but it's about the use of machine learning in science in general. So is there a way forward where trust and community can help guide us? Possibly. First of all, we all know how the open source model is being successful to support scientific research, but also industrial applications. So one question is this model applicable to large language models? And Yang LeCun, who's a very prominent scientist, and he works for Meta that released Llama 2, thinks so. So he sees a future where open source models and code exist, and people will fine-tune them for their purposes. There are groups working on generating like crowdsourced content that can be used for this fine-tuning. And there's also approaches that try to see whether this information, additional information can be patched into existing models rather than building them from scratch. And here I wanted just to highlight the activities of the University BD Collaboration. Is a group of self-organized group of people interested in this technology working on these projects. So I invite you to see what they've been doing. I'm at the conclusions. I know my time is up. So let me just summarize what I've been trying to convey in this very successful and transformative service, I think, to the community. So we went through technology evolution and sort of sociological evolution of our own team. What we've been able to accomplish thanks to the support from NASA is quite remarkable, but it wouldn't have been possible without the contribution from a number of people that we I truly stand on the shoulders of some giants. I just want to point out Steve Murray, who was the original ADASS PI from the very beginning. Michael Kurtz who's still with us, but he provided the vision for the ADASS as is today as a literature service. And Gunther Eichhorn that joined, that was the project lead initially through 2007. And the rest of our team, too many names to mention, but here we are at our retreat in September. Happy bunch of folks. So from all of us, thank you so much for the prize and for your support.
If there are any questions, but you know where Alberto is, and I'm going to allow the online audience to ask questions first, since they're not here.
Okay, we have one online question so far on Slack. So what fraction of ADS visitors still prefer the classic form over the new form?
I don't know at the moment. Actually, I was asked this exact question a few days ago, and honestly, I haven't been checking this. It's a sizable amount. It's astronomers who do this. All the new, let's say, users of our system find a way around the one-box search. But don't worry, I mean, ADS is evolving, but that form is not going away. So you can still use it, as far as I'm concerned, until I retire.
Hi, same way. I really appreciate the historical context from how many activities you've had throughout the years with the buildings. Can you make a comment on associating all of your employees? Like, at what point was it just the dean versus actually we need to hire full-time software engineers to maintain projects?
Yeah, so the question was about the sociology of running a team and whether, going from a bunch of astronomers to software engineers changed the nature of the group. It definitely did. So I think everybody, on the plus side, everybody in our team, I think, has a sense of the importance of the project overall. And so, even if some of our developers' background was in applied math or computer science or information science, they still chose the project because of its impact, not because of the money that we're giving them, which wasn't that much, as you can imagine. I think the other thing that I came to appreciate over time is that not only you want people that have excellent technical skills, but it's important to build a team of people that work well together. And sometimes those things are at odds. So you have to find really the right recipe and the right personalities also to contribute.
Okay, let's thank Alberto one more time, and we're out of time for questions.